Hello students. Today we're moving on with lesson number 2, the area of a right triangle. So the first thing we're going to do is kind of talk about how we develop the area of the right triangle based on our understanding of a rectangle. And that's why this rectangle is over here. Now you don't have this on your piece of paper, so you might want to pause the video and just go ahead and draw it in with the lines in between. You don't need the X here, but please draw the lines in between. So if you need to pause the video, otherwise let's go ahead and get started. It says use the shape labeled with an X, that's this over here, to predict the formula needed to calculate the area of a right triangle. Um, explain your prediction. Well, we're just going to kind of talk about our prediction as in the explanation, but we're going to go ahead and we're going to use the area of a rectangle to develop the area of a right triangle. Now, you forgot what a right triangle is. This is from our previous lesson. Remember, this is a right triangle here. And it has a right angle on kind of connecting two of the sides together, as opposed to an acute triangle, which does not have one of the right angles connecting the two lines or two sides together. So we're going to form the formula for the area of the right triangle. Well, remember, finding the area of a rectangle is just simply base times height, also known as length times width. So if we go ahead and kind of label that, if I label this as the base, also from a parallelogram, and label this as the height, if I multiplied these two together, I'd find the area of the whole thing here. Well, remember, this is a rectangle, so there's a right angle right here. The question is, how can I convert this or change this into a right triangle? Well, if this is a right angle here, I can go from one of the corners. I'm going to try to draw this as straight as possible and just simply cut this in half. And now we have a right triangle. As you can see, it looks very similar to this right triangle right here. There's a right angle in the corner, and it gets cut from one corner to the other. And this is exactly what we're doing. The area of a right triangle is simply base times height. Well, we don't want this side over here. Remember the right triangle. I'm going to go ahead and kind of shade it in a little bit. This is the right triangle, this kind of red section over here. So I don't need this extra piece over here. Well, that's half of it. If I cut it from corner to corner, that's half of a rectangle. So that's how we develop our area for a right triangle. So right here where it says area of right triangles, go ahead and put A for area is equal to, and now we're talking about we want 1/2, and we're going to multiply it by the base, and we're going to multiply that by the height. So as you can see, the base times height is the area of the entire rectangle or parallelogram, but we only want half of it, so we cut it in half. That's where the half comes in. So there you go. This is our area for a right triangle. Now it's base times height, so just like a parallelogram or a rectangle, and then we just simply want half of that. Remember, commuted property. I can do this on the end if I wanted to. So now over here in the next one, it says the area of the given triangle. So now we're going to find the area of this given triangle. So let's go ahead and kind of go through the steps. So we're talking about 1/2, and then times. Well, the base here is 3, and we don't know what these are, so we're going to label it U for units. Times the height is going up to, right? 1, 2. So we don't know what these are. So once again, units. So now we just need to do the multiplication. Well, if I multiply 3 times 2, 3 times 2 is 6, and then multiply 1/2, half of 6 would be 3 units. And of course, we're talking about the area, so of course we have to put the square. I don't have mine set up to put the square up top here, so I'm just going to go ahead and write it in. All right, so there you go. So the area of this is, of course, 3 units. Now, if you think about this one, if we would have cut this in half horizontally right here, there's 3 units on the bottom. So that makes perfect sense about why this area would be 3 units. All right, so let's go ahead and go on to another one. Okay, now just kind of looking at our right triangle and using our formula. Just go and write it in. We have area equals, and we're talking about 1/2 times base, which of course is B, times height. So I'm just going to kind of leave this up here as kind of a reference. So find the area of this. So just like our parallelogram, we want to find that right angle. So there it is. So area equals 1/2 times the base. Now I'm just going to kind of leave the units out. I'm just going to go ahead and write the numbers in, which is 15. and then times, and then the height, of course, is 8. So I want to go ahead and do the multiplication. Well, I can multiply left to right if I wanted to, but the multiplication of 1/2 and 15 isn't good. So I'm going to go ahead and multiply these two together. Commutative property of multiplication says it doesn't matter. So I'm going to bring down the 1/2. I'm going to do the multiplication of 15 times 8. So let's go ahead and do that on the side real quick. I don't know what that is off the top of my head. So it's okay to do the work on the side. 8 times 5 is 40. So go ahead and carry the 4. 8 times 1 is 8 plus 40 is 12. So there's 120. So I want 1/2 times 120. So I want to know what is half of 120. Well, half of 120 is just simply 60. So the area of this right triangle would be equal to 60. And now I would like to put the units in. So I like to just simply work with the numbers and go, okay, what were my units? They were feet. So let's go ahead and just input the feet squared. And that's perfectly fine to do. All right, a little trick to this is, now if this trick confuses you, don't use it and it's okay. But a little trick to this is I need half of one of these two numbers. I have a 15 and I have an 8. Well, if I have an even number like 8, I can take half of 8 very easily. So if I took half of 8 is 4. Well, what is 4 times 15? So once again, this is like a little trick that you know from that you can use because of the commutative property of multiplication. Is if I took half of 8, that's 4. Well, what is 15 times 4? Well, if you do the multiplication, 15 times 4 is actually 60, is the answer. So if you notice, there is an even number here and you can take that half quickly. That's perfectly fine to do. Just don't let it confuse you. Once you take the half of one number, you're done. You don't want to take the half of 15 or take the half of 60 again. Okay, I took half of 8, which is 4, multiplied it by 15, and I get 60. And of course, that's my answer. So that's just kind of a little trick. Don't use it if it's confusing. If otherwise, just simply multiply the two whole numbers together and then take half of it. And remember, taking half is the same as dividing by 2. I'll kind of do that on problem number 2. All right, that's our first one. So go and stop what you're doing. Go ahead and pause the video. We're going to move on to question number 2 and 3, and then one other exercise.